Okay, today we're going to be talking about the shell method, and what I want you to have is a strategy for solving one of these problems that you can go to, just get the basics down in your head and give yourself a starting point that you can use when you get to the AP exam. So first of all, what you need to know about the shell method is what it is you're summing up. What you're doing is you're finding the volume of a bunch, actually infinitely many little shells. They're basically just cylinders. They've got a little bit of thickness to them. That thickness is what shrinks down to zero as you include more and more shells. But, your shells are going to look something like this. And if you can come up with an expression for the volume of this little shell, then that's what we're going to integrate. Basically, you have a bunch of those little shells, and they just kind of sit together, sort of like those little Russian dolls, or um, like a set of like measuring cups that you have at home in your kitchen. Um, you don't have to write this down, but if you have a little measuring cup, and then the next little measuring cup sits down into the first little measuring cup, and the next one sits down into that one, and they just nest together like little Russian dolls. That's what you're adding up, a bunch of shells. So let's talk about how big or what's the volume of this particular shell. To figure that out, what if you just cut that shell right down the line and then unrolled it? If you unroll that same shell, all it is just a little rectangular solid with a little bit of thickness. Okay? When you unroll, the length of this top side is the circumference of the circle, and the circumference of a circle is pi d. Instead of it, being the circumference up here, being pi d, we've just unfolded that same shell to make it look like a rectangle. Okay, so this dimension, the height, whatever the height of um, your shell was, that's going to be one of the dimensions of your rectangle as well. So we'll just leave that as height. And then however thick your shell was, we'll call that dx. It could be dy, but we're going to go with dx in this case. So most of the times it's dx. So what's the volume of this shell? The volume is pi times d times, actually let me go back. Instead of calling this d, let me call that pi times double the radius. All right, so my volume is equal to 2 pi r times h. So what you need to know about the shell method is you are going to integrate with a 2 pi on the outside, wherever your limits are, x equals a to x equals b, of, on the inside, you need a height and a radius. Doesn't matter what order. So if you can remember that there's a 2 pi on the outside and there's a radius and a height on the inside, that's your go-to memory trick. Radius and height is what you need. Now, you don't need to every time be thinking about this cylinder and unfolding it and all that. Ideally, you're going to go in thinking I need 2 pi on the outside and radius and height on the inside. But if you happen to forget and you're not sure and you're confusing with the disk method and all those things that could go through your mind, you can picture the shell and picture cutting it and unrolling it and figuring out what its volume is. So let's do a quick example. In this example, I want to rotate this area that is contained by the x and the y-axis, the line x equals 2, and the graph of x squared plus 3. And to make it a little more interesting, I'm going to rotate it around this line, x equals negative 3. So I like to sometimes do a little sketch and see what my volume is going to look like. My new shape is going to be over here, and it's going to look about like this when it goes into the board on the other side. You don't have to do all this, but I just kind of like to get a picture of what I'm dealing with. It's going to kind of be, I don't know, sort of like a stadium almost, with an emptied out middle. So what do you need to know about the shells? Each shell is going to come from rotating what we call a representative rectangle. These rectangles start down here. The first one would be 3 units tall. The second or the last one would be 7 units tall, and everywhere in the middle. Those are our representative rectangles that are going to spin around to create these little thin shells. You just have that one. And what you need to know are just two things about this shell. You need to know what's the height of this shell and what's the radius of this shell. Well, I would even start with my basics. I need my radius, and I need my height, and I'm going to do dx. And since this is a vertical rectangle, everything's in terms of x. My limits of integration are going to go from 0 to 2. My 2 pi is a constant with the shell method. There's always a 2 pi with the shell. And I need to know two things, the radius and the height of each shell. Now, these are going to change as we move from the first rectangle to the last, so they're going to be in terms of x. So, here's the radius of each shell. The radius of each shell goes from the axis of revolution over here at -3 over till I touch the graph. So, from the axis over to the graph, this little line right here has two names. We could either call that x, or we could call that what x is equal to in terms of y, which would be, if we were to rearrange this equation, we would subtract 3 and square root of y minus 3. So that little piece of area, let me change colors, this little area right here in purple can be called either one of those two things. So which one do I choose? I choose to call that x, because everything's in terms of x. Now, my radius of each shell is going to be 3 plus x, because I have this consistent 3 here. I've got that 3 along with x. So the radius of each shell is 3 plus x. And what's the height of each shell? Well, this distance right here, the height of my representative rectangle, two names. I can either call it y, or I can call it what y is equal to, x squared plus 3. And since everything's in terms of x, I'm going to use that one. And then sometimes this is going to be an integral that you evaluate by hand, by multiplying it out and integrating and subbing in and all that. Sometimes it's going to be one where you just substitute in. So there's our quick crash course on the shell method. Just remember, 2 pi on the outside, radius times height on the inside, and then with more practice, coming up with expressions for radius and height will get easier with time. All right, so there you go. This is Young, and I'm out.